シリーズの第2回目を、本日今より開催したいと思います。日本時間で今、5時を過ぎたところでございます。改めまして参加ご登録の皆様、参加の皆様、ありがとうございます。おかげさまで本日までにですね、280名を超える大勢の皆様に参加登録をいただいております。今、続々と40名以上、50名に今、届いてますけども、皆様参加をいただいている最中でございます。それではですね、今から約1時間半のセッションですが、3方の講師、その中でですね、リーダーを務めていただいてますペロリアインサイツのですね、大石さんにマイクを渡したいと思います。大石さん、お願いします。
ありがとうございます。Well, from now on, we're going to switch to English version of the session. So thank you so much, Naito-san, for having this. And thank you, everyone, for joining this webinar session. I think Naito-san has explained at the very beginning of the last webinar, but this series of the session is all about the intersection of three components, which is peace building and then technology and social investment. For today's webinar, we will be focusing on two of them, which is technology and peace building. And then we will have a guest speaker as well as breakout Q&A session. So there are a lot. So let's get started on that. Following this introduction, we will have panel presentation where speakers will give 10 to 15 or 15 to 20 minutes presentation. Meanwhile, you can, of course, give us questions that you have in your mind using a chat box. In Japanese, in English, either way is fine. But also, you'll have opportunity to give questions directly during breakout session. So keep that in your mind and then just develop some of the questions you may have at the very end. Can you guys all see my screen, by the way? Okay, perfect. To start off, I hope this is a presentation mode. Okay, let's see. Okay, to quickly introduce myself, my name is Ayaka Oishi. I am a project manager and also political analyst at Peloria Insights. I'm sure 99% of you may not have heard of this company because it's a startup company based in the United States. And then mainly we are predicting conflicts on the ground using big data and AI. A recent project which I will be sharing quite soon includes the predicting conflicts in Democratic Republic of Congo, as well as Somalia, Kenya, and South Africa. So those are things that I've been doing as my day job as well. In addition to that, I was lucky enough to do research this peace tech field supported by Fulbright scholarship a couple years. So that is one of the opportunities for me to explore what's going on in terms of the peace tech field in the United States especially. And then that was the reason that I was given this opportunity to present what I learned throughout these experiences here today. I also joined by Elham and also Yusaku here. Elham is a later remote sensing as well as machine learning scientist at Space for Good. Space for Good is Netherlands-based company specialized in satellite imageries. And she will be explaining her background soon, I think, in her presentation. But Space for Good is one of our collaborator partners of Peloria Insights, and then we are implementing a project altogether to predict conflicts at DLC. Yusaku is a senior innovation officer at a World Bank Group, and then he has a strong background in not only machine learning, but also policy-related field. So that's how he's going to explain as a third presentation today. Also, let's see. Yeah, as I mentioned, there will be breakout Q&A session at the very end. And then in this session, we will be separate this room, and then you will choose one room to go, and then just to have discussions with the speakers as well. In room 2, in addition to Elham, we have also guest speakers, Takeshi. He is a PhD candidate of the University of Tokyo, and then his specialty lies in machine learning and causal analysis of it. So if you would like to talk about a little bit technical side of things, then Doom 2 is definitely the one that you may want to jump in. Okay, without further ado, I think I'll start my part of the presentation, and then which is about Peacebuilding. First, I would like you to ask, what is Peacebuilding? Maybe some of you guys may have already heard about this Peacebuilding trend, but maybe it's your first time to hear or know about this term Peacebuilding. To simply put, a Peacebuilding is a technology-enabled products or services. It could be tools, it could be application, it could be any types of project that leverage technologies here. But purpose is all about the peace building. So it could be help foster relationship between conflict parties, or to protect people from the direct effect of conflicts. Or it could be addressing root causes of the conflicts. And then seeing all the examples that I will be presenting in a moment, these are the core purposes of the Peacebuilding. Well, the word Peacebuilding is well used, but at the same time, there's a lot of other way of saying these days. So it can be part of ICT for D, or it can be AI for peace, or big data for peace. There are a lot of variations, but core principle, in my understanding, is the same. It's a technology-enabled services or products for peace building. Is Peacebuilding new? Well, the answer is not really. Actually, the word, very first timing that the word comes up was around 2008 and 2009. It's more than 10 years ago. It started from USIP Innovation Center. USIP in Japanese, it's Beikoku Heiwa Kenkyūjō desu ka ne. And that was one of the initiatives driven by heavily connected with the US government at the very beginning. And also around the same time, UN established UN Pulse Lab. I think it was first in New York, then Kampala, Uganda, then I think also Jakarta these days. And those organizations may not necessarily use the word Peacebuilding, but started practicing or researching these kind of concepts that leverage technologies for peace building effort, or in the context of fragility and conflict and violence. And 2014, around this time of the year, Peacebuilding Lab, which is one of the leading NGOs in this field, has established. And also some of the international conferences have been held, which includes Build Peace. It's an annual event. And then, of course, it's online these days, so you can definitely join that for this year, or Peacebuilding Summit, etc. This year and also last year, 2020 to 2021, there are a lot of exciting news, which includes UNDP's Innovation Cell. Some of you may have heard of I think she's a Japanese expert in UN, but there is very interesting organization established called Innovation Cell, and they are using big data to, for example, catch the dialogue between two conflicting ethnic groups, or using AI to predict things. Those projects have been undergoing through this Innovation Cell approach. And World Bank published data for Better Lives. Well, it's an annual report published by World Bank, but this year, World Bank has a specific focus on the data. So that's kind of highlights how this Peacebuilding or AI for peace type of movement becomes more prevalent these days. Okay. So this chart shows how I understand each implications of Peacebuilding project. As I mentioned, there are a lot of programs and projects, so-called Peacebuilding, but it's always difficult for me to understand the context. So this chart is what I rely on the most of the times. Y-axis here is talking about how advanced the technology is. So if you find a keyword like AI or blockchain, then that's one of the advanced technologies as opposed to easy to use technologies, which is like SMS or internet online platforms or things like that. And the x-axis here is talking about the target. So if we are targeting the population or civilians under conflict, that's here, as opposed to policymakers, perhaps government agencies or international organizations. As Peloria Insights, what we are doing is here. It's called conflict early warning using AI, and then use this predictive information for policymakers. So that's what I will be sharing the detail. But also there is another interesting project that I really love. It's about bomb alert. This use AI, so it's advanced technology, but also it's targeting the people. So in that case, this kind of implications belongs here. There are a lot of implications that I want to share, but because of the time constraints, I will just share two. But Elham and also Yusaku can be able to show more of that. And if you're interested in more than happy to share those implications with you. So definitely let me know even later in our presentation or after this webinar sessions. Okay, in terms of key actors, there are a lot. In terms of the governmental organization, as you can probably imagine, USAID is one of the key actors. And also, for some reasons, government of Netherlands is also a strong actor around this field. It actually defines security strategy with focus of the conflict early warning supported by big data solutions. And then they have been supporting financially as well as human resource-wise a lot of these kind of innovative projects as well. International organization, as you can imagine, is also key actors here. World Bank, as I mentioned, has some not publishing reports like on data, but also had some programs that leverage AI-based information for financing model that I will be sharing, and also Global Pulse and DPPA Innovation Cells. In terms of civic organizations or private industries, it's very difficult for me to list up everything here because there are a lot, but these are some of the key organizations you may perhaps want to look at in Google. Danish Refugee Council is a NGO, but I think they are the first one who collaborated with IBM to predict the conflicts in this sphere. So they're one of the leading experts on this field. Peace Direct had some programs focusing on peace tech. They may not necessarily use advanced tech, they may just use easy to use type of technologies, but have implemented a lot of those kind of applications on the ground. And the HALA system, that's one of the companies provides bomb alerts using AI. And also Build Peace is the organizations who is hosting yearly event on Peace Tech. And the Tech Change has offered some of the Peace Tech related online courses for practitioners like ourselves. Okay. Got into the details of the some of Peace Tech applications. This is one of the applications that offers AI-powered bomb alert in Syria. And then this has been argued that one of the big success in the field of peace tech. HALA system has a lot of observers, just human observers, or IoT, Internet of Things, that is placed on the ground, and also using some of the news media sources. They build algorithm to calculate where and when bomb will be made in Syria. And then they sent this information using SMS to the local population. It will be not like there will be bomb attack or airstrikes in like 2 months or something like long term. It's just like within 5 minutes or 2 minutes sometimes. But it's good information enough to hide in a shelter or look for a safer place. They do this using AI and also, as you can see, a lot of data, and it sends more than 100 warnings per day, which results in quite a huge number of the reduction rate in casualties. And then this mechanism, they now, I think, only has a implication in Syria, but they are looking for the other implications of other countries so that they can save more lives. That's one of the great example of the peace tech that targets people. As opposed to that, other example is the peace tech implication targets policymaker, which is what I do in my daily job. Using similar data, but not exactly same. I'm using big data like social media, online news data, as well as satellite imagery, or some of the economic indicators. We predict conflicts, what trend in conflicts in next 30 days or 60 days or 90 days in this time span. And then we provide this kind of information to mainly international organizations so that they can implement better development activities on the ground. Most of the common question that I received these days is that how do you collect the information about the conflict? How do you know when it happens or how it happens? Actually, there is a quite good number of conflict event data set available online, and then most of them are free. This conflict event data set tracks killings or assassination or looting or sexual harassment, these different types of conflicts on the ground every day. And then they provide a CSV or Excel file tracking all this information. So in the case of Democratic Republic of the Congo, which I've been doing, for past 5 years, there is like millions of data sets like this, and then which can be used to train our machine learning model so that we can predict the violence in the future. So there is some of the limitations, of course, in terms of which country can be tracked. But when it comes to predicting conflict, we can rely on this kind of open source data for free. Okay. So to wrap up some of the peace tech implications as well as trends, of course, there is a lot of considerations against implementation of peace tech activities. The first key consideration is about privacy and data protection, because this involves very specific context of the conflict. If we got data that is violate human rights or in terms of the privacy rights, it could be a huge problem. Especially some of you guys may have heard of the issue of the Cambridge Analytica. That's one of the incident around Facebook data. But because we are relying on data and AI, those privacy consideration is always right up. And then that's something we need to carefully plan it out before implementing any type of peace tech implications. And ethics is also other type of consideration. Yes, we do provide predictive information to international organizations for now using open data. But who owns this data? That's the question. Is only elites at international organizations can have access to these predictive data, but not others, not populations. Those aspects also has to be well considered, although there is not global consensus on that for now. And when we talk about AI, of course, there is always issue of embedded bias. So even though we try to minimize the bias in algorithm, it's quite difficult to completely remove those because the humans provide data and then select what variables to put. So when you have any chances to implement peace tech projects or using like high level of predictive analysis, those considerations might be something you may want to consider at the very beginning of the project. In addition to that, throughout my experiences and work as a peace tech practitioner, as I call, there is some key lessons for successful peace tech projects. First point is that I often received questions whether people need to learn how to code or details of the technicality of the project. The answer is no, no coding skills needed at all. But it's very important perhaps for you to understand what kind of implication is available out there, because there are a lot of Peace Tech projects already implemented across the globe. It's quite easy these days to get an idea from those past projects. So if some of you wants to learn more about what the possibility or what's the implication for you, I would highly recommend you to look at past projects and get an idea of what you want to design as a project. And also the second key lesson that I've learned is that it's quite important to design a project alongside with the technologist. Usually when we design a project, I think it's a common custom to design with social science experts, like conflict experts or country-specific experts. But at the same time, if it comes to Peace Tech project, you may want to understand the technical ability of the project itself. So I would highly recommend you to get data scientists or any type of specific technology experts so that you can design project in collaboration with those type of experts. And also, as a third point, stakeholder management is key here more than any other project, in my opinion, because it's very attractive to say that we are using AI or we are using big data. That's so trendy. There are a lot of attentions may coming to your project, but it's not always like the success of this Peace Tech project is not always guaranteed. So invest in stakeholder management and then control their expectation is one of the key lessons that I've learned throughout this project. And last but not least, paying attention to the context specificity is everything, because each conflict, each group has a different narratives behind it. So you cannot fit any type of methodologies to everything. So that's maybe something you can rely on the more country experts on that, or any types of field managers or field experts, so that you can learn the context specificity of the project. Okay, that's my quick presentation on Peace Tech trend. Next, I'll hand it over to Elham, and then she will be sharing her story at Space for Good, as well as some of the implications regarding satellite imageries. Over to you, Elham.
Thank you very much, Ayaka. It's a pleasure to meet you all, and thank
Oh, you are muted.
do you hear me? Thank you very much, Ayaka, for the introduction and for introducing the panel. It is a pleasure to present. I will share my screen. And yeah, let's start. It is loading. Just a few minutes until it is. Can you see my screen now?
It's still work in progress.
Oh.
Do you want me to share your screen instead? Oh, I think it's coming.
Is it? Or maybe you can share if it is not, please.
Sure, of course.
Just a moment, maybe I can try once more. So, do you see my screen?
Not yet.
I have it here. Strange.
Oh, yes, it's
okay.
coming.
Maybe we can. Okay, it is coming. So, do you see it?
Yes.
Great. I will present our work at Space for Good, a company based in the Netherlands, as Ayaka introduced. And the title of my presentation will be Remote Sensing and Artificial Intelligence for Peace. I will introduce you different projects. My name is Elham Goumehei. I have did my PhD in Japan University. It's a pleasure that present in the technology for Peacebuilding in the Japanese webinar. And I would like to say konnichiwa to everyone. Sorry, my Japanese is not good enough. But going through the presentation, the agenda for my presentation will be just an introduction about our team, who are our clients, what are our services, what tools we use, which is GIS and remote sensing. I will go through it, a perspective on peace and safety application, what are the benefits, what are the challenges, and finally, I will introduce you some case studies that will be an example of what we are doing. We are a geospatial company and we use novel innovation sources and actionable geospatial insights to increase the efficiency of data transparency and understand help to understand more about data. Our team is based in the Netherlands. We have the Humanity Hub. You can see my colleagues in the photo, and we are working in a young and in a motivated group that have different kind of projects, which peace the conflict application is one of our projects. The services that we have is about monitoring and detection, assessment and mapping, modeling and predictions of the events, and the effect of geospatial data and satellite data to see how it can help to use the data and improve our understanding about the world. But the data that we are using, with GIS and remote sensing, geographic information system and remote sensing. I will introduce you quickly. With the remote sensing is the knowledge of using the satellite data, satellite images, taking images with satellite over the Earth to see what is going on the Earth. The optical remote sensing data are working on the daylight. That's the same as our eyes are working, seeing those wavelengths and the things that we can see with our eyes. We have different, we call these passive satellites because it is working with the sunlight. And there are different satellite data that are collecting on optical images. Landsat 8 is one of the very famous current satellites. Sentinel-2, Worldview, and many other passive satellites. There are other data, radar remote sensing, which is working by itself. It is sending wavelengths and receiving the wavelengths, the backscatter from the Earth. So this data, we call it active remote sensing. The data, because it is sending and receiving by itself, it is independent from the sunlight and can work during the night time or maybe the cloudy situation. The Japanese satellite ALUS is one of the most famous ones. Sentinel-1 is the European satellite which is collecting data with radar remote sensing. Here I am showing you the wavelength and frequency that these different data are working. The active sensor and passive sensors, you can see different colors. For example, the optical sensors that I was talking are working in the visible range, the thermal, infrared with specific wavelengths. The radar data, which is shown in red color, is working in different bands and different wavelengths. So sending different wavelengths we receive different backscatters, and it gives us information. Every object on the Earth has different backscatter, so we can understand these backscatter is related to each object on the Earth. And GIS, or Geographic Information System, which we use it to simplify the work and understand and model it, and to see what is going on the world in a simplified version. The data, the imagery data that we are using is one of the sources that we use. The elevation of the Earth is one of the can be one of the layers, the addresses, the maps that we have, the water features, all the boundaries that we have, all of this information overlaid together, and try to understand what is the real world, try to model the real world. But what is the application of these data on peace building and warnings and conflict situations? The benefits that these data has is that we can map and monitor the changes. We can map and identify the suspect areas that we are looking. We can delineate the boundaries, the desired boundaries that we have. We can have a large overview of the conflict area, the places that we are looking the conflict situation for. And in case of high resolution data, for example, we can understand the dimension and type of demolished area, the depicted area that we are interested. But these data, there are some challenges using this data. For example, here you can see two types of images, the same image of same area, but the right side is a high resolution image and the left side is a lower resolution data. So the resolution is a constraint, is a limitation for satellite data. Usually high resolution data are commercial, we should pay for it, but the lower resolution data usually are public and we can use it. In case of the peace and conflicts, we don't have the wide validation data. This is a lack of validation data that proves that the changes that we are seeing are related to the conflict. We have low temporal resolution. As I explained, the satellite data are flying over the Earth and collecting data, but it is not like all the time data. It is not a real time data. They are passing, for example, the Sentinel-1 and 2 are passing every 6 days over the Earth. So this is not the case. Or ALUS is 10 to 14 days passing over the same location. So we have low temporal resolution. We call it temporal resolution. And as you can see here in the urban areas, there are those white, bright pixels which are saturated. So they cannot give us too much information. It is specifically for lower resolution. Higher resolution, you have less saturated pixels. So these are the challenges we tackle with the current available data. I'm sure that in future there are advanced, they are improving, and we will have more and more higher and better resolution data in case of temporal and resolution. I want to just after this short introduction of what is remote sensing and GIS, just explain you some examples that we worked on to give you an overview what we exactly had a project, Carter Center based in the US, that they were working on conflict zone detection. They approached space for good to explore what is the possibilities and how satellite data can help to verify assets and monitor the military conflicts that they have this explosive weapon contamination in the areas, and they want to understand and verify and assess that what is this contamination, how these explosions can be detected and monitored. We were working in Syria, two different provinces, Aleppo and Idlib, Harim district in Idlib province and Al-Bab district in Aleppo. And for validation, we had some ground confirmation of ammunition distribution in that's provided by LCD, that Ayaka was also mentioning that organization, and the Carter Center, that they had access to this data. But the geospatial data that we have used, we use Sentinel-1 and 2 data, the optical one, Sentinel-2, which is, we have used different bands, B2, B3, B4, with different reflections, and as I explained shortly. And Sentinel-1, which is radar data. We have used the VV polarization, and both Sentinel-1 and Sentinel-2 data has 10-meter resolution, means each pixel shows you 10 meter squared on the Earth. Then we have used 2 methods, optical change detection and radar multi-temporal change detection. The optical one is pixel-based and the object-based. I will explain you that the optical change detection is the pixel, the first approach was pixel-based. We used a time series to detect patterns. This time series means that for each pixel, we were looking from 2015 to 2020 of the images of Sentinel-2 for each pixel to see if there is a sudden change in the pixel. We have, of course, removed the seasonal changes and to see like what is if there is a change in time for each pixel. The other approach was the land cover classification, that we try to classify the pixels as vegetation, as a bare soil, or other pixels, which can be urban areas, water, or whatever. For the time series, here is the results. Of course, the results are overlaid on the high resolution data. These green yellowish pixels are those pixels that are shown that there is some changes happening, but you can see the resolution that we were working on is not the same as this high resolution. So we can see some different what are these changes, not say what are these changes. But the other approach, land cover classification, which I classify the land based on the black dots are the locations of recorded explosions. The green is what we detected as vegetation. Brown is the air soil, and the white other, the urban area and water, or what else which is not vegetation or which is not bare soil. You can see that there is a correlation between bare soil and explosions. Like where there is an explosion, is more bare soil happening in that year. Each image is showing 1 year of classification of data, 2016, 17, 18, and 19. Another approach that I talked about was object-based classification, which we tried to classify each area based on an object, for example, a bare soil, agricultural land, and urban areas. Here is the result, of course, overlay on the high resolution data. The conclusion for optical data that we have used, the data that we were using was 2 coarse resolution. It is not desirable for detecting changes. We can detect the changes, but we cannot say what are these changes. But land cover patterns follows the impacts that we were looking. The object classification, we can see that significant differences, but in a small locations. We cannot still validate these differences. Because of this, we go to the radar data to see how we can multi-temporal change detection in radar data. We have used different, for 6 images for 6 years, from 2015 to 2020, see what are the changes happening. We used VV band because the changes are more obvious to these images, and we did some pre-processing steps that are very for processing the radar image, because they are not like optical images easily understandable. Here is the results. The changes, you can see that those yellow colors are the changes happened, and those red dots are the recorded explosions. 1988 explosions happened between 2015 and 2022. What we did further to validate the results is that defining a buffer zone around these recorded areas, 250 square meters. See it is to define a border for the bombardment location, and we find this bombardment effective or make contamination in the area with 100,000 changes happening within this buffer area. Based on these definitions, we could classify the bombardments as effective. For example, between 2015 and 2016, within 355 recorded bombardments, 75 of them were effective. They affected more than 1,000 square meters on the area. The most worst scare was 2016-17. They had 242 effective bombardments. They rained in more areas in this year. And here we mapped the effective explosions. The yellow colors are those bombardments that made changes in the area. They caused demolition in the area, buildings or other changes in the area. For the radar conclusion, we can say we can detect changes. It is capable of detecting the changes happening in the area. We use a threshold to not consider all of the changes. So it is helpful to just filter out the changes. The buffer zone increases the confidence of changes detected. It means that we classify the bombardments, those are the effective ones. But here again, with the radar data, we cannot determine what are the changes, and we need more data to understand what are the changes. In the case of urban areas, we had many saturated pixels, which doesn't give us more information. The other project that we had was with Halo Trust that we had in Citre. We called it Citre ruin detection. Here we use also the same approach of optical time series. This optical time series, as I explained, that going to each pixel to see what are the changes between a year. Using this data, we could understand, we could detect the second war in Citre, which is nice to detect. Of course, it's not nice to see the conflict and the military situation in any part of the world, but we could understand and discriminate what happened. You can see it on the northern part of the image, the kind of yellowish brownish color in the city happening. We use the amplitude differencing from radar data, kind of the same results with the time series, but it is not as accurate as the optical data. We use another approach with high resolution panchromatic data, black and white data. We try to define different neighborhoods and see how the changes is happening. The algorithm could detect the ruined area. The yellow color shows high change. In the upper image, you can see that how the changes is happening in neighborhoods. It is from blue to red, from low to high changes. So the more red colorish areas are those areas that are damaged more. The conclusion with Hylotrust project was that we can say that with time series, we can detect the time of changes, when these changes happen, and if it is related to any bombardment. And with high resolution data, we can detect the destroyed building and destroyed neighborhood. So both of these data can be complementary and give us the information that we are looking for. We had other projects with different partners that I quickly just mentioning. For example, fire detection and deforestation. It's not necessarily about the explosions and military activities. It's about human activities as well that causes conflicts in the area. Fires that people drive due to the environment, due to the poor situation, economical situation in the area, people making fire in the forest, and they make environmental degradation and economic extreme rainfall falls with the SDA that I show you what is happening in Congo. Ayaka was also mentioning the common project that this impact of climate shocks, how it can causes the changes. What we do as a space for provide the spatial data, and our partners are working on AI-based models to predict the social conflicts in the area. The drivers as to spatial data, the vegetation index, land cover, crops, deforestation. What I was explaining that we have a common project with SDA that looking for impact of climate shocks to see how the changes can cause the conflict in the area. If you go for the next slide, I will. Yeah, what we do as a space for good using geospatial data, some drivers of the conflicts like land cover, vegetation index, soil moisture, temperature, all of this they are providing. And then having this data as input information, we have AI-based models that our partners, as was explained in the previous presentation, using AI models, machine learning to predict the social conflicts might happen. If you go for the next slide, then I quickly sum up my discussion that early warning can help us avoid social conflicts, and what we do for this is using drivers, the measurable data to versus the social conflicts that sometimes is not easy to measure it. So we use these measurable data to predict and to prevent the social conflict happens. Chances of actual social conflicts, we cannot validate it. Actually, it depends on how we validate it and how we define the social conflicts. But it is more complicated than measurable drivers. Anyhow, all of us try to have a better overview and with early warning and early action prevent from social conflicts. Thank you very much for your time, and sorry again for the interruption that happened in my presentation.
Okay. So just to wrap up today's webinar, I just want to Elham and also you, Saku, to share a little bit of the conversation you had, and then if there's any great questions that you answered and you want to share, could you do that, please?
Elham, do you want to go first?
Yep.
Yeah, thank you very much. Yeah, thank you, Jessica-san. We had questions, obviously technical questions about machine learning methods that Takeshi-san also helped me to answer the questions that how to improve the deep learning approach for classification, how to improve the results, that there are suggestions that cross-validation, reinforcement learning might improve the results. Also, sorry, questions that how the approaches for classification can help the understanding the conflict areas in case of moving immigrants or immigrations of people, moving people in the area, if the NDVI approach can help the same as classification, which I believe both are kind of the same. In case we have more information for classification, so that is more desirable, but NDVI is the fastest and I can say accurate enough to have the first insight, good insight of the problem.
Very good. Thank you so much for sharing that. What about you, Yusaku?
So in my group, there are a couple of questions about how ITS Technology and Innovation Lab actually works. Also, a little bit of discussion on what kind of data we use to build up machine learning model. So I just, briefly explained that, World Bank sometimes has access to data from partners, meaning that developing countries. Or we also have internal data sharing platform. Those who can communicate with private sector and get their data. So for example, using that platform, we can have access to data from Facebook, Mapillary, and so on. So many, unique data sources. And also there is another platform that is focused on remote sensing data, satellite imagery. So we can have access to those data as well. And also we have a lot of, open data and synthetic data. So that's a little bit about what kind of data we often use to build up a machine learning model in order to make a prototype. And also we discussed about talent retention. So one of the uniqueness of Technology and Innovation Lab is it's a good mix of business experts and also technical resources, technical experts. So it could be a little bit challenging sometimes to make sure that we have a good talent who can work on all kinds of potential problem solving. So that's an important aspect, and we are trying hard to make sure that we have a good talent who are those who are kind of edgy, and we also have some PhD candidate from in computer science from, for example, like top school like Johns Hopkins. So that's how we try to make sure that we are competitive in terms of technical expertise. So those are the couple of points we discussed in the group.
Great. I totally agree with that, especially when it comes to this kind of innovative approaches to do. I think diversity in human talents or resources is quite key to excel. So that's something that I totally agree with. But in our session, I've got really great questions on that. Okay, now we have predictive information. Can we stop violence? Well, that's the longest standing question that I'm asking always to myself. Having the information doesn't mean that we can actually intervene, or we won't actually intervene. So I think next step of this early warning related to system is to actually propose what kind of intervention would be the best to take, or what cost would involve if we do not take any actions against it, so that policymakers have less choices but to intervene. Well, that's something that we will be trying in the next couple of years, not something that we see right now, but I think that's the future of the early warning, especially early warning systems. Okay, just to wrap up today's webinar, I just wanted to share what's next. So if some of you became very interested in this kind of peace tech field or innovative approach on peace building, there are a lot of resources to do so. The first thing that I would like to recommend is that join the Facebook group, which is called Peace Tech Japan, or you can find me on Facebook with Ayaka Oishi, and then I will let you in that group where we discuss or share the approaches of peace building or peace tech activities. And also sometimes we call for members to do some certain project. So definitely join that. And then if you want to learn more on desktop, then perhaps you may want to enroll Digital Peace Building 101 provided by BuildUp. you can learn a lot of implications there, and that's for free. So definitely recommend to do so. And also one of my close friends who are working hard to publish ICT 4D textbook in Japan, in Japanese in 2022. So if you not only Peacebuilding, but if you want to learn more about development activities using ICT, this is the go-to book that you may want to get. And as I think a lot of you guys may have heard of this ICT 4D lab and also blog, there are a lot of posts related to Peace-Tech and also general programs and activities relating to the technologies and data or AI. So check out these resources so that you can build some knowledge on this field. And then we are very excited to learn each other from for further opportunities. Okay, I think this, oh, sorry, I passed a little bit of that time, but Naito-san, over to you. That was from our session. Thank you so much.
All right, thanks very much, Oishi-san, and thanks so much, Elham and Kawashima-san, and Ishima-san also. Thanks for your contribution to the Q&A session, especially. どうも皆さん、長い間ありがとうございました。ちょっと時間が超過しましたけども、日本時間でいうと6時半、過ぎましたけども、ありがとうございました。大変長時間、ただ非常に、濃いセッションだったと思います。来週ですね、予告を若干、来週23日水曜日、また5時から日本時間で始めたいと思います。来週、皆さんお気づきだと思いますけども、先週第1回目はですね、イントロダクションという形で、一つの国、スーダンをフォーカスしました。で、今回、テクノロジーに特化した形で、特にサテライトテクノロジー、それからビッグデータアナリシスに特化した形でお三方に登壇いただきました。来週はですね、さらに若干一歩踏み込む形で、ソーシャルインベストメント、社会的投資の可能性が平和構築にどう掛け算できるのかと。河野さん、もう皆さんご存知だと思いますけども、日本を代表する、社会的投資の実践の第一人者です。中村さん、JICA の職員でありながら、今、慶應義塾大学で深い研究をされていらっしゃいます。お二人にご登壇いただくことになっています。ぜひ、引き続きご参加ください。それではですね、また来週も皆さんにお会いできることを楽しみにしております。アンケートをですね、チャットの方に、斉藤さん、シェアしていただいてますかね。シェアしていただいてますね。アンケートをチャットの方にシェアしてますので、よろしければアンケートを、もう1、2分で終わりますので、お願いいたします。また今日の動画はですね、第1回目と同じように公開いたしますので、ぜひ見直して勉強していただければと思います。それでは皆さん、今日はこの辺で終わりたいと思います。ありがとうございました。Thank you so much, Elham. Thank you for your joining from the long distance way. Okay, thank you. Goodbye, bye bye. それでは皆さんごきげんよう。バイバイ。
ありがとうございました。
川島さんもありがとうございました。
ありがとうございました。
優作